care of. The fourth step is to find the horizontal asymptote. And I get sick of writing vertical asymptote and horizontal asymptote over and over. So from now on, when you see, when I write VA, I'm talking about vertical asymptote, and when I write HA, I'm talking about the horizontal asymptote, all right, just to shorten things up for us. All right. To do step 4, I'm going to not write down the steps right now, all right? I'm going to do it as I do a problem, because this is the confusing part of this whole thing, all right, this one right here. Okay, now we've got that. Step 5. And let me just pause for a second. I've got 15 minutes. We're checking that it's rational. We find the X-intercepts. That's going to be dots on our X-axis. We find the vertical asymptotes, which are going to be these vertical barriers. We find the horizontal asymptote, which is going to be these things that pull our function down at the ends, right? These magnets at the end of our function. Now what we need to do is going to be, it's kind of different from this. What we need to determine now is what's happening on the inside of our function. So what we're going to do is find test points using the X-intercepts and vertical asymptotes. Plot those test points. You have no idea what I'm talking about right now, okay? And that's okay. And then 6, last step, use your brain, that thing on your shoulders, in your skull. Use brain to draw. All right, let's just try and run through this one right here. Okay, we're just going to do that one. And when we come back to class next time, we'll do the other 2. All right? All right, first step, is it a rational function? Yes, right? Polynomial, polynomial. Great. Step 1, check. Step 2, find the X-intercepts. So to find the X-intercepts, I'm going to set the numerator equal to 0. So I set x plus 1 equal to 0, and that gives me a solution of x equals -1. I'm going to box it, right? And I'm also going to write something else here, just to remind myself. This is a point on the x-axis, right? That is an actual point that lives on my graph. It's the intercept of the function, right? It's where the graph hits the x-axis. Step 2. Step 3. What's step 3? Verticals. So to do the verticals, I set the denominator of the function equal to 0. So I set x squared minus 2x minus 8 equal to 0. And what are you going to do to solve that? Well, that depends on you, right? You are either going to factor it or you are going to use a quadratic formula, right? It's up to you. I am going to factor it, only because it's faster for me to do it that way. Factors like that. And that gives me 2 solutions, 4 and -2. Is everyone clear that you might have to use a quadratic formula there? And that might take you an additional couple of minutes to do that? All right. Next. Oh, wait, I need to talk about these. What are these? This was a point on the x-axis. What are these? These are those vertical dotted walls or barriers, right? Right, when I draw these, they're going to be vertical dotted barriers. that my function, when it gets to them, is going to like either want to go up or down, right? It's going to depend on the function. But the important thing is that these are not x-intercepts. These are not dots on the x-axis. These are barriers. All right, questions at all? Y'all look thrilled. Fourth step, horizontals, right? Horizontal asymptotes. So I didn't tell you how to do this, did I? Okay. I don't want to overcomplicate it, but it is somewhat complicated. What we're going to do is we're going to come over to our rational function and we're going to compare the degrees of the numerator and denominator. So the degree of the numerator was 1. We talked about this in the very beginning, right? The degree of the denominator is 2, right? The numerator's degree is smaller than the denominator's. I told you there were 3 different cases, right? We could either have this is smaller than this, or this is bigger than this, or they're the same. In the case that the numerator is bigger than denominator, so in this case, the numerator's degree is bigger than the denominator's degree. Whenever that happens, automatically the x-axis is your horizontal asymptote. Every single time the numerator's degree, oh, sorry, I have that backwards, don't I? The numerator is not, the numerator's the top, right? I have it backwards. If the numerator's degree is smaller than the denominator, which is what we have here, right? 1 is less than 2. 1 is less than 2. Then the x-axis will be our horizontal asymptote. In class next time, we will look at the other 2 problems that we're going to do. Those are the other 2 cases. So we'll see what happens when this is backwards or what happens when they're equal. But the good news is when the top's smaller than the bottom, your x-axis is your horizontal asymptote. If you look at the problem we did that I graphed, 1 over x, that problem that we actually did the t-table for, the degree of the top here is 0, because there's no x's in there, and the degree of the bottom is 1. So you have this case, and when we drew it, we had dotted lines coming out the x-axis. Right? So it's following the same format here. Okay, what's the 5th step? Find test points using the x-intercepts and vertical asymptotes, plot the test points. Okay, so let me try and kind of motivate why we're doing the next step, step 5. I'm going to have to erase all this. Right now, here's where we stand. Here's what I know about my graph. I have an x-intercept at -1. It's a dot, right? I know that much. I know from step 3 that I have vertical asymptotes. I have 2 of them. One of them is at -2, and the other one's at 4. And what were these? At -2 and 4? Vertical dotted lines. Right? I also know from step 4 that I have a horizontal asymptote on the x-axis. Do not draw your dotted line all the way across the axis. Just do it at the ends. The horizontal asymptote is like an end behavior. It only tells you what's happening out here. It does not tell you what's happening in here. Let me say that again. Never draw your horizontal asymptote all the way across. It only tells you about what's happening at the ends. I'm going to say that one more time. Never draw your horizontal asymptote all the way across. Always draw it at the ends, because it tells you about what's happening at the ends. Let's do it one more time. Don't ever draw the horizontal asymptote all the way across. That's the biggest mistake I see. All right? Because as soon as people draw a dotted line across here, they think they can't cross it. And the thing is, you can do everything. There's all sorts of crazy stuff that can happen in here. The dotted lines are only about the ends. That's all it's about. Okay. That's where we are right now, right? That's how much we know about my graph. There's so many things I don't know still. I don't know, I have no idea what my graph looks like over here. No idea. Over here, Like I have one dot, big deal. I don't know if this thing like goes up or down. I know there's a barrier, so it's going to have to go up or down. Not sure what it does. And then in here, I have no clue. And then over here, I have no clue. Do y'all see there's just so much I still don't know? So now what I'm going to do is I'm going to pick some test points. And so when I look at this picture, I want to pick a test point in each place that I don't know what's going on. So like, see this dotted line? See to the left of it, we don't know anything? I'm going to pick something over here. What's a value? Notice I put an X and I didn't put a dot because I don't want you to think that's part of the graph. What's a number over here? -3. I'm going to circle it. Okay. How about, here's that dotted line, here's this dot. I have no idea what's happening between here and here. No idea. So let's pick something in here. Unfortunately, it's going to be a decimal. -1.5. Okay. Now, between this dot and this vertical, I have no idea what's going on between here and here. So any number between here and here, what do y'all want? 1? 1. Okay, and then from this vertical to the right, I have no idea what's happening over here. So I'm going to pick something over here. How about 5? So do you see how I say here, find test points using the X-intercepts and vertical asymptotes, and then plot those test points. What do I mean plot those test points? What do I have to do with each of those numbers? Plug them into the function. Shit. Yes, this is your life right now, okay? That means I have to take -3 and plug it in here and see what number I get out. I have to take -1.5, plug it in here and see what number I get out. I have to plug 1 into this function and see what comes out. And then I have to plug 5 in there and see what comes out. That sucks, right? Yes? But that's what we have to do, all right? So because I only have 5 more minutes, I'm going to do it more mentally and quickly, all right? So f of -3, when you plug let's do the first one. We'll do the first one together. -3 plus 1 is going to be what? Yeah, I'll put it here. -3, so this is what we're doing. We're doing -3 squared minus 2 times -3 minus 8. So we're going to just calculate that whole thing. So we get -2 on top, and on the bottom we get 9 plus 6, 15, take away 8, 7, -2/7. Okay? Y'all see that? So at -3, right, here's 0. At -3, I'm supposed to go down 2/7, right? All I want you to care about, though, is that it's below. So just anywhere you want, put a dot down here. Now that dot's part of my graph. That dot's part of my graph, right? Okay, now we plug in -1.5, and we have to plug it in here and do that, get our calculator out and figure it out. I'm not going to show the steps. You're just going to have to trust me. When you do that, you get a positive number. It's right here. I'm just going to put it above. Y'all know what I mean by positive? Just up. This one was negative, so down. Okay, if you plug in 1 into that, you should get a negative number. Down. And then if you plug in 5, you should get a positive number. You'll understand the amount of work that would take, yes? And you have to get them all right, which is, just adds to the complexity. All right, we're almost there. We're ready to draw it. We're done. We've plotted these test points. Now we must use our brain, and we must draw this picture. You ready to use your brain? No? I wish I could bottle the looks on your faces right now. It's pleasure. I would call it would be a bottle, and then it would just say pleasure on it. That's the look I see on your faces. All right, who's going to help me with this? I need somebody who can think critically here. I need to draw a function that, is curved, kind of like the one we drew earlier, but I have these barriers here. What can you tell me about this? If you look at this point, so I'm going to start at the far left. If I have to draw this picture out that way, what has to happen? And why? What do you got? What do you got? No? You don't know? If I draw it this way, could I do this? Is that okay? Why not? Why can't this go down? It has to, what is this thing? That's my magnet, right? This thing pulls functions towards it as you get close to it. So this right here tells me that from that point, I must go towards that. Come to me. Right? Like this. Now, from the same point, trying to draw this way, what happens? We start going along, and then all of a sudden we see this barrier, right? We see this barrier. So what do barriers make us do? Either turn up or turn down, yes? So is it up or down? Get a coin? What is it? What is it and why? Down, why?
Because you can't pass that other asymptote.
So let's just say it turns up. Okay, let's say we're coming this way and it turns up. Oh, shit, what did I just do right there? Right there, it turned up, right, oh, right there. What happened? I made a new X-intercept. See, if you turn up, you are creating an X-intercept that doesn't exist, right? This is the only X-intercept that exists. So it can't turn up. It must turn down. See, it's a process of elimination. So that means it goes like this. Then you move to the next dot, and you go out the left and right, same way. So if I go out to the left, what happens? Oh, barrier's in my way, right? I either have to go up or down. Which way is it? Up, because if I go down, what happens? I cross through again, can't do that. So I'm going to have to go and turn up, like this. What if I go to the right? What happens? Start drawing to the right. Oh, there's a dot. I have to get to that, right? So we're back in kindergarten, we have to connect these two dots. So I just draw a little curve. There we go. And then from this dot, where do I have to go? To that dot, right? Nothing in my way, no barriers, nothing to worry about. I just continue through. Do, 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 boom. And then I come out that side and I'm like, do, 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 and then I see it, right? You see it? Got a barrier. Which way am I going? If I turn up, I'm going to create an X-intercept, right? I got to go down. Okay, this dot to the left, what happens? It's got to go up. Can't come down, right? Can't. No X-intercepts. Got to go up. And then to the right, I'm almost done. To the right, what? This thing pulls me down towards it. Come to me. There you go. We're done. That's the graph. Yep, pleasure, right? 20 ounces of pleasure. Okay, we obviously need to do a couple of more of these, yes? All right, so I think you can see how these problems kind of just encompass so many different things, right? Like you have to be able to factor, you have to be able to solve quadratic equations, linear equations, you got to be able to evaluate functions at points. And if one thing is off, the whole graph is off. So, yeah, fun. Work on, check your email later. I'll send that polynomial exercise thing. Otherwise, that's all you've got for homework. We'll get into this later. Have a good weekend. What you got?
Quiz from last time that I didn't
Okay.
answer.
Okay. Yep. Thank you. Who the heck?